In the world of aviation, understanding RVR is crucial for ensuring safe and efficient flight operations. RVR, or Runway Visual Range, provides pilots with critical information about how far they can see down a runway during takeoff and landing. This measurement plays an essential role in various weather conditions, significantly impacting flight safety and airport operations. Understanding the concept of runway visual range is crucial for both pilots and airport operations. RVR provides a specific measurement of how far a pilot can see along the runway, which directly influences flight safety during takeoff and landing. In this video, we will explore what RVR means in aviation measurements, its differences from general visibility, and how it is calculated. If you are ready, let's start with the definition of the RVR. Runway Visual Range, RVR, refers to the maximum distance at which a pilot can see runway markings or lights from the cockpit during landing or takeoff. Essentially, it's a critical aviation measurement that quantifies visibility conditions on runways, particularly in low visibility situations like fog or heavy rain. Understanding the RVR aviation, meaning helps pilots make informed decisions about whether to land or take off under challenging weather conditions. Difference between RVR and visibility. While both RVR and general visibility pertain to how well one can see, they are not interchangeable terms. General visibility measures how far an observer can see horizontally across an area, while RVR specifically focuses on visibility along the runway's length as experienced by pilots. This distinction is vital because it highlights that even if general visibility is acceptable, runway-specific conditions may still pose significant challenges. Thus, understanding what is RVR in aviation measurements becomes essential for safety. So, how RVR is calculated? Calculating runway visual range involves sophisticated techniques that account for various atmospheric factors affecting light transmission. The process typically uses laser technology to measure how much light is scattered or absorbed by particles in the air between the pilot and runway lights or markings. By applying AIKO standard algorithms alongside data from environmental sensors, accurate assessments of visual range are made possible, ensuring pilots have reliable information on what they can actually see when it matters most. How RVR is used in flight operations. Runway visual range plays an integral role in determining whether an airport can safely accommodate aircraft arrivals and departures under varying weather conditions. When weather reports indicate low visibility due to fog or heavy rain, pilots rely on accurate RVR measurements to make informed decisions about landing or taking off. In essence, understanding what is RVR in aviation measurements directly influences operational protocols at airports. Air traffic control uses real-time RVR data to manage aircraft movements efficiently while maintaining safety standards. For instance, if the reported RVR falls below minimum thresholds for a specific runway approach procedure, air traffic controllers may delay landings or divert flights until conditions improve. Consequently, accurate assessments of runway visual range are vital for effective flight operations. Additionally, pilots are trained to interpret meta reports that include crucial information about runway visual range. These reports guide them on whether they can execute approaches safely or if they need to consider alternate airports due to insufficient visibility levels. From a pilot's perspective, understanding runway visual range is paramount for ensuring safe flights during challenging weather scenarios. Pilots often rely on their training and experience when interpreting these measurements. Knowing the difference between what is RVR in aviation measurements versus general visibility can affect their decision-making process significantly. The ability to gauge how far they can see down the runway helps them assess landing distances and prepare for potential go-arounds if necessary. In conclusion, acknowledging the significance of runway visual range not only enhances individual pilot performance, but also contributes positively to overall aviation safety standards by minimizing risks associated with poor visibility conditions. Pilots can get RVR information in the meter reports. Meter reports are essential for conveying real-time weather information to pilots and air traffic controllers. These reports include various data points, including temperature, wind speed, and notably RVR values, which indicate how far a pilot can see down the runway. When deciphering a meta report, it's important to focus on the RVR segment, typically expressed in meters, which directly informs the crew about visibility conditions critical for safe flight operations. The format of a meta report includes specific codes that detail RVR readings alongside other meteorological observations. For example, an RVR reading of R05 per 1000 indicates that the runway 05 visual range is 1000 meters. If the RVR is greater than the maximum value that can be measured, P will precede this value. If the RVR is less than the minimum value that can be measured, M will precede this value. If RVR trends can be measured, then U, D, or N will follow the RVR value to indicate increasing, decreasing, or no change respectively. Understanding these codes allows pilots to quickly assess whether conditions meet safe landing criteria based on established regulations regarding what is RVR in aviation measurements. If you want to know more about meta reports, you can watch my video about detailed meta reports. In wrapping up our exploration of RVR and its significance in aviation, it's clear that understanding RVR aviation meaning is essential for both pilots and air traffic controllers. The concept of runway visual range provides a crucial metric that determines how far a pilot can see the runway environment, influencing landing and takeoff decisions. This understanding not only enhances flight safety, but also optimizes airport operations. If you find this video helpful, you can like the video and subscribe to my channel for more aviation-related contents. Thanks for watching. See you in the next video. Goodbye.